Welcome to 8.1, where we are going to be talking about probability. This is where this last page of curriculum comes from. So we have to learn about simple probability before we can move on to compound probability, multiplication rules, things like that. You probably have seen problems like all of these in this section, but I still wanted to go over them. So here we go, simple probability, section 8.1. All right, so this is note card 251, and it's just some simple probability definitions, experiment, outcome, and sample space. An experiment is an investigation or a procedure with varying results. An example of that would be flipping a coin. You can flip it and get heads up or tails up. An outcome is a possible result from the experiment. Like from flipping a coin, your outcomes are you can get heads up or tails up. The sample space is the set of all possible outcomes. So with flipping a coin, your set of all possible outcomes are you get heads up or tails up. And notice the squiggly bracket notation means a set. We've been doing that all school year with numbers, and the comma means you just have different things in that sample space. So pause me and finish up note card 251. All right, note card 252. Let's look at this. I want you to give the sample space and the number of outcomes for each experiment that's given in this example. Now keep in mind, we had a sample, I gave you an example of flipping a coin. Your possible outcome was heads, but your sample space was all of the outcomes that you could get with that set notation. So here I want the sample space and the number of outcomes. So a state that begins with the letter O is chosen. So Oklahoma is a state that begins with the letter O, and there might be some more. You may need to look this up if you don't know all your state names. So you need to think about all of the possible outcomes. You have Ohio, Oklahoma, and Oregon. Okay, so this is your sample space. It has the squiggly brackets with commas, and there's only 3 outcomes that you could get. Okay, now what about this one? A day of the week is chosen. Well, what days are there of the week? There's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So that is your sample space, and there's 7 possible outcomes. Real simple, but I need you to understand possible outcomes and sample space. So go ahead and pause me and finish up note card 252. All right, note card 253. A probability definition and some other information. Okay, so let's find it a little bigger. I don't know why I did that. Okay, so yeah, we talked about some simple probability definitions of experiment, outcome, and sample space, but now what does probability really mean? What is it? Okay, so there's a couple ways that a couple things I want to talk about. Probability is a measure of the chance of a specific event occurring, okay? So the chance that, what's the probability that when you flip a coin, you would get tails up? What's the probability that if you get a deck of cards that you would pull out a spade, okay? So this is the chance of a specific event occurring, and we note it as P of E. Now to you, that might look like P times E, but with probability, we use capital letters, and it's the probability of the E, of the event. So if I wanted the probability of getting tails up, I would put P of T, probability of tails. So it's really in context of the question. The next thing I want to talk about is how it's expressed, how probability can be expressed. It can be expressed as a ratio of favorable outcomes to the total number of outcomes. Okay, the ratio can be written as a fraction, a decimal, or even a percent. So there's 3 ways you can write the answer for probability: a fraction like 1/5, a decimal like 0.2, or a percent like 20%. Now, any of them are acceptable unless the problem specifically says to answer in a certain way. As we progress further in our math careers, the most acceptable one is a decimal. But right now, it probably makes sense to you to say a percent, like that's a 30% probability or a 20% probability. But again, it can be written as a fraction, a decimal, or a percent. Lastly, I want you to know that any event probability that I'm talking about, the sum of all the probabilities in this sample space would be equal to 1. And you will see that as we do some examples. So go ahead and pause me and finish up note card 253. All right, so let's jump into a spinner example. So here's a spinner. I know it's not the best quality image here, but it's got numbers 1 through 16, starting this way, 1, 2, 3, see them all? Yes. And numbers 4 through 11 are shaded, okay? So the directions are give each probability as a fraction in simplest forms. Like you wouldn't want to leave it as 4/14 or whatever. You want to simplify it. They also want you to give it as a decimal and a percent. So all three ways to represent a probability I want you to get used to, okay? So the spinner below is used in a game. If it is spun once, find each probability. So there's going to be some little individual questions here. Okay, so this first one is this is the probability notation. What is the probability of spinning a 9? That's what that means. So part A is probability of spinning a 9. Well, if you look, there's no 9s repeated. There's just one 9 out of 16. So what would the probability be? Well, it would be 1 out of 16 because there's one spot that's a 9 and there's a total of 16. So that's the simple fraction. And then you type it in your calculator and you get your decimal, 0.0625. And then to get your percent, you just move the decimal place over twice and that would be 6.25%. Okay. Now the next one is the probability that you get at least a 12. At least a 12. So they can ask that type of question too. So at least a 12 means you need to have 12 or larger. So 1, 2, 3, 4, 5. There's 5 of those, 12 or larger, out of the 16. So that would be 5/16. That does not reduce. So that's your fraction. Type it in your calculator and you get 0.3125. Move your decimal place to the right twice, and that's 31.25% probability. All right, the next one, what's the probability that you would get a perfect square? So you really have to think, what are my perfect squares? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So we have 1, 2, 3, 4 perfect squares on here, okay? And so it'd be 4 out of 16, which does reduce, okay? 4 out of 16, they want you to reduce to simplify, so it'd be 1/4, which is 0.25 or 25%. All right, so what's the probability that it's not shaded? So how many of these are not shaded? 1, 2, 3, 4, 5, 6. There's 7 of them not shaded out of 16. So that's going to be 7/16, which does not reduce. And there's your decimal and there's your percentage. Now, E, what's the probability that you would spin a 2 or an 11? A 2 or an 11. All right. 2 or an 11. Well, there's just one 2 and there's just one 11. So that's 2 out of 16, which reduces to 1/8. And there's your decimal and there is your percent. Now, what's the probability that it's a multiple of 5? So your multiples of 5, 5, 10, 15, 20, 25. But on here, it only goes to 16. So we have 5, 10, and 15. So there's 3 out of 16. That doesn't reduce. There's your decimal and there's your percentage. So this was just a simple example of a spinner and a fair spinner actually, and how to represent your probabilities in the 3 ways that you can write your answers. So go ahead and pause me and finish up note card 254. All right, so here's just some more examples, and it is note card 255. So this one, a month of the year is chosen at random. How many months are there? There's 12. Find each probability. So they're going to ask me some individual questions here. Let's see. And they are using the probability notation. Okay. Okay. All right. So the probability that the month starts with a J. So I'm going to look up, I know we know the months of the year, and I know we can count this, but I know that a visual will help. Months of the year. Okay, here they are, right here. Here's the months of the year. Oh no, that's not what I meant to do. Okay, we're going to look right here at the months of the year. So what's the probability that it starts with the J? So there's 1, 2, 3. There's 3 of them that start with the J. So it would be 3 out of what? What's my total samples? There's 12 of them. So it'd be 3 out of 12, which reduces to 1/4, which is 0.25, which is 25%. So what's the probability that it starts with a T? Okay, let's look. Are there any months that start with a T? I don't think so. So what is that probability? It'd be 0 out of 12, which is 0, 0, 0%. What is the probability, let's see, that the month that we pick has at most 30 days? At most 30 days. All right. Oh my goodness. Okay. Well, that's not. We're gonna look at this one. Oh goodness, what is that? Okay, we're just gonna have to let, here's what I can do. I can copy the image and I can bring it over here. Okay. So let's look at this for a hot second. All right, so this tells me the number of days in a month. And guys, I used to do this when I was little using my knuckles. I don't know if any of you know that little way to do it. But remember, the question is, what is the probability that the month we pick has at most 30 days, meaning no more than 30 days? So January has more than 30 days. February never does. So we're looking for ones that have 30 or below. So I'm going to start counting. 1, 2, 3, 4. January, March, April, May. That's weird. I think June has 30 days. I don't even think this is right. This isn't even right. Hold on. I really am glad that I checked that knuckle analogy when I looked. There's one right here where it talks about the knuckles. So I'm real curious. I'll have to ask you guys that in our next class period if you know what I'm talking about. But here they are. And again, we're looking where it has at most 30 days. So we count February, April. So 1, 2, 3, 4, 5. There's 5 of them. There's 5 of them. So it'd be 5 out of 12. And there's your decimal. There's your percentage. Okay. Man, I was like, that can't be right. Just goes to show everything on the internet is not right. We've had this discussion on my second block a lot. Just saying. Okay. All right. What is the probability from this? I'm sorry. A letter from the word probability. It's chosen at random. Find each probability. So what's the probability that you're going to pick a B? Well, there's 2 B's, and I got to count the total letters in the word probability. And so there's 11. So it'd be 2 out of 11. There's the decimal, and there's the percentage. The next question is, what is the probability that a vowel is chosen? Well, a vowel, A-E-I-O-U, right? So 1, 2, 3, 4. So the O, the A, the I. So there's 4 of them. 4 out of 11 does not reduce. There's 4 11s. There's the decimal. There's the percentage. And then what's the probability that you would pick a Y? Well, there's 1 Y. So 1 out of 11, and there you go. All right. So go ahead and pause me and finish up your note card 255 with your month and letter examples. Here's just an example you don't have to do a note card on, but it tells you about a pencil box. It contains 5 red, 6 yellow, 8 blue, 3 orange, and 2 purple colored pencils. If one is chosen at random, find each probability. All right, so what's the probability that you would choose a yellow? Well, there's 6 yellow. Well, how many total things are there? There's 24 if you count them up. 5 plus 6 plus 8 plus 3 plus 2. There's 24. So it'd be a 25% chance that you would pick a yellow because there's 6 of those. All right, what about if it's a blue or a purple? So I would add the blue and purple up. Where's the blue? 8 and 2, so 10 out of 24. And that reduces to 5/12, which is this decimal and this percentage. And then what about it not being orange? So there are 3 oranges. So if I do 24 minus 3, there's 21 colors that aren't orange. So that'd be a 21 out of 24 chance, which reduces to 7/8, which is an 87.5% chance. All right, now before we do the next example, I have been surprised throughout the years how many students do not know what a standard deck of cards consists of. So you've got 4 suits, that's what we call them. Spades look like this, hearts like this, diamonds like this, and clubs like this. Your clubs and your spades are black, and your diamonds and your hearts are red. You have ace cards, And then there's not a 1 card. You have ace cards, and then you have numbers 2 through 10. And then you start with the jack. So it's got a J, the Q for queen. So it's got a Q, a K for king. And that's your 52-piece standard deck of cards. There's 52 cards. All right. Okay. So if a card is chosen at random, from a standard deck of cards, find each probability. Okay, so remember, we're looking at this, a standard deck of cards. You do not include the jokers. All right, so what is the probability that you would draw a queen? So let's look back at this. How many queens are there? There's only 4. So your probability would be 4 out of 52, which reduces to 1/13, which is 0.0769 or 7.69% chance. Harpy, what is the probability that you would draw a 3? A red 3. So you've got 4 3s, but only 2 are red. So you have 2 red 3s, so it'd be 2 out of 52, which reduces to 1/26, which is that decimal and that percentage. Now, what's the probability that it's a spade? Now, your spades are all of these. That's a quarter of the deck. So you know it's 1/4 or 25%. But how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 spades. So it'd be 13 out of 52, which reduces to 1/4, 0.25, or 25%. It's going to pause me and finish up note card 256. All right, now I want to move on to another definition of what it means to be a complement of an event. It's not like what you think where, ooh, I really like your glasses being a complement. When we're talking about probability, that is not it. So the complement of an event is the probability of the event not occurring. So when I look at this, the complement of this part A is actually 48 50-seconds or 12 13ths. It's the complement of it where it wouldn't happen, okay? So it's like the opposite. Since the sum of all probabilities in a sample space is 1, the probability of an event not occurring is this notation, probability of, and it has that little squiggly, but that means not. And let me do this real quick, see if it'll let me. Yeah, probability of the event not happening. That means not. And I know you can't see it very well up there, but that's what that says, okay? And what you would do, like if I want the probability of not getting a queen, I would do 1 minus the probability of getting a queen, because it's everything other than that, okay? So we're going to do some examples of that. So go ahead and pause me and finish up note card 257. All right, so here's some examples of the complement. If the probability that it will rain tomorrow is 3/8, so you are given a probability in fraction form. What is the probability that it will not rain? You simply do 1 minus 3/8, and you get 5/8, and there's your other ways to write it. This one, if the probability that someone will win a game at the carnival is 1/24, what is the probability they will not win? You do 1 minus 1/24, so it'd be 23/24, so I'm in the 95.83% probability they're not gonna win. All right, number 10. A number is chosen from 1 through 20, okay, at random. What is the probability it's not prime? I paused myself and wrote down the prime numbers between 1 and 20. Remember, 1 is not prime. The first prime number is 2. There's 8 of them. So what we would have to do is just 1 minus the prime probability, so 8 out of 20, and you get 12 out of 20. Or you could just count all the numbers that aren't prime. All right, if a state is chosen at random, what is the probability that it does not begin with the letter M? Again, I'd have to look at all the states, but there are 8 states that start with the letter M, so I would do 1 minus 8 out of 50 to get that probability. All right, it's just another way to do it. And yes, you could do the total opposite. You could just go, like I said, find all the states that don't start with an M, and that would be 42 of them out of 50. Just finding a complement is sometimes quicker, doing it by finding the ones that do start with an M and then subtracting. All right, so pause me, finish this up. That's actually the end of the video on simple probability. Great job, guys.